Okay, f of x equals e to the x times cosine x, and we want to find the average rate of change from 0 to pi. So we're just going to plug in. We have e to the pi times cosine pi minus e to the 0 times cosine 0 over pi minus 0. This is just, we would say, f of pi minus f of 0 over pi minus 0. This is our average rate of change formula. So then it's going to come down to really what these trig values are. Cosine of pi is -1. Cosine of 0 is +1. E to the 0 is also +1. So what we end up with then is we have this to negative e to the pi, because we have e to the pi times -1, minus 1 over pi. And we can just leave our answer just like that. Next, it's asking for the slope of the line at x equals 3 pi over 2, which is just a way of saying f prime 3 pi over 2. So to determine that, we're going to have to figure out f prime x first by applying a product rule. So we have a derivative of e to the x is e to the x times cosine x, the second function, plus we are going to leave the first function e to the x alone and multiply by the derivative of the second function. Derivative of cosine is negative sine. So what we should do then is say that this is going to be a negative. So we're just going to, instead of adding, it's going to be subtracting, and then it'll be sine x. So we have e to the x cosine x minus e to the x sine x is our f prime x. Now we're going to plug in 3 pi over 2. So do f prime 3 pi over 2 is e to the 3 pi over 2 times cosine of 3 pi over 2 minus e to the 3 pi over 2 times sine of 3 pi over 2. So cosine of 3 pi over 2 is equal to 0, so this whole term is going to cancel. And then sine of 3 pi over 2 is equal to -1. So what we're ultimately going to end up with then is we have negative e to the 3 pi over 2 times -1 is going to make a positive. So overall, this is going to be equal to positive e to the 3 pi over 2. That is the slope of the function at x equals 3 pi over 2. To determine an absolute minimum, we need to know when f prime x is equal to 0. F prime x is equal to this, so let's copy that over. So it's e to the x cosine x minus e to the x sine x, and we want to know when this is equal to 0. So what we should do is factor out the e to the x that is part of both terms. So we get e to the x is times cosine x minus sine x, and that's equal to 0. And then we know that e to the x is never 0. So what we really need to determine is when is cosine x minus sine x equal to 0? When is cosine x minus sine x equal to 0? Because that's going to tell us when f prime is equal to 0, and that's going to help us find our absolute minimum. So they're going to be 0 when they're equal to each other. So when we think back to our unit circle, okay, they're both cosine and sine are positive in the first quadrant, and they're both negative in the second quadrant. So they're going to be equal at a reference angle of pi over 4 when they're both equal to positive root 2 over 2, and 5 pi over 4 when they're both equal to negative root 2 over 2. So we have x equals pi over 4 as an option. X equals 5 pi over 4 is also an option. But this is a function that is going to cycle between 0 and 2 pi. So our other options would be it's at a minimum at x equals 0, or also at a minimum at x equals 2 pi by just checking the endpoints of the interval. So we have to plug in these 4 values to the function. So we can start with f of pi over 4 equal to e to the pi over 4 times cosine of pi over 4. And then we have f of 5 pi over 4, which is e to the 5 pi over 4 times cosine of 5 pi over 4. Okay, and then we also have f of 0, which is e to the 0 times cosine 0, and then we have e to the 2 pi times cosine 2 pi, and cosine 2 pi, just like cosine of 0, is 1, so that's just going to give us positive e to the 2 pi. So now let's go back here. So cosine of pi over 4 is root 2 over 2. And then cosine of 5 pi over 4 is negative root 2 over 2. So what we have is we have a positive number, we have a positive 1, and we have another positive number. The only negative number is this one. So we should write this one out a little bit better, but this one has to be the smallest because it's the only negative one. So f of 5 pi over 4 is e to the 5 pi over 4 times negative root 2 over 2. So then that'll make the whole thing negative. So that is our absolute minimum. So this part D is asking us to evaluate the limit as x approaches pi over 2 of f of x divided by g of x, where g of x is this function they gave us. So the first thing we should always try to do with a limit is just plug straight in f of pi over 2 over g of pi over 2. And this problem gives us that g pi over 2 is equal to 0. And then we know that f of pi over 2 is 0 because that is, if we look at the function f of x, it's e to the pi over 2 times cosine of pi over 2. And cosine of pi over 2 is equal to 0. So then that's going to give us 0 over 0. And because g prime is differentiable, it's continuous, so we have L'Hopital's rule that's coming into play now. So this limit is going to be the same as the limit as x approaches pi over 2 of f prime x over, or f prime pi over 2, I should say. Well, yeah, so it's f prime x, and then we're going to plug into that. Okay, so f prime x over g prime x. So this will be equal to f prime pi over 2 over g prime pi over 2. So what is g prime? We can pull it straight off of the graph. G prime pi over 2, this is the graph of g prime, here's pi over 2, just equal to 2. So 2 is our denominator. Our numerator is going to be f prime pi over 2. So we need to look at f prime x. F prime x is e to the x times cosine x minus sine x. That's just from earlier. So all we need to do is replace x with pi over 2, which is going to give us e to the pi over 2 times, let's just do this here, cosine of pi over 2 is equal to 0, and sine of pi over 2 is equal to 1. So this is going to be 0 minus 1, which is negative 1. So this is going to be negative e to the pi over 2. That's our f prime pi over 2. So then we can just plug that in right here. We get f prime pi over 2 is negative e to the pi over 2 divided by 2. And again, the whole point, the cornerstone of this problem is that you're allowed to apply L'Hopital's rule because g prime is a differentiable continuous function and f is a differentiable continuous function. And when we did this limit, we got 0 over 0. So then that's what brings L'Hopital's rule into play.